Hi, everyone. Welcome. We are really excited today to have two affordable housing passive house projects, multifamily. Both of these are in Massachusetts, and lots of really interesting lessons being learned. The first is Harbor Village, which is 30 units in Gloucester, and the second is North Commons, 53 units in Northampton. And we've got a great lineup today. So Michelle and Tom are on the first project, the Gloucester Harbor Village project. Michelle as the designer and Tom as the verifier, passive house verifier. And then we have an even different perspective from Chris, who's the project manager for community builders on the North Commons project. And I'm just going to talk a little bit. So both of these projects are projects that received grant funding through Mass CEC's Passive House Design Challenge. So this was over 3 years ago. Mass CEC kicked off sort of some incentives to encourage affordable housing to go ahead and design and certify to the Passive House standard. So we provided up to $4,000 per unit for 8 projects. And 2 of these are built, Cambridge, Finch, and Harbor Village along the top. 4 of them are under construction and pretty far along. So the project Chris is going to talk about is actually about 80% complete. And then the other 2 have just recently broken ground. And so it's really exciting because all of them got funding. We weren't always sure they were going to get low-income housing tax credits, but they all did. And so far, we've been seeing pretty low incremental costs. So these are not all final complete because there definitely can be change orders that could affect these, but we're seeing between 1.4% and 3.8% with so far an average of 2.4%. That's really encouraging. The number one cost across all 8 projects for an increase in cost from like a more basic design that could have been gone to is around ventilation. And honestly, after COVID, like, shouldn't we be putting in great ventilation in all of our multifamily buildings? I think it's a pretty easy sell for some of that incremental cost. The rest of it, you know, there are some real increases in costs. I think none of us will disagree with that. It is interesting to see how it varies from project to project and what we can learn from that. And so getting into the weeds of these projects, I think, is really interesting. Also, as part of our Passive House Design Challenge, you know, part of the reason people might want to do Passive House is because it's not that much more expensive, but the flip side has to be true too. Are we really getting the lower energy use that everyone's promising with the Passive House standard? And so we've been taking a look at projects that have been built for a couple years now and trying to compare them to code built and sometimes lead projects as well. And some of the logical places to look for that is in communities where there's energy disclosure ordinances. So Boston's one of those great examples. So if you just take a look at what was disclosed in 2019, you sort for multifamily buildings, you look for ones that were built after 2010, and you can cross-reference against which ones are passive house certified and which ones are LEED. You get this chart, right? So the green on the left side is the only multifamily building that has been built for a while in Boston, the Distillery, which the picture is on the right. The energy use per square foot is very low there, 20.4. So it is giving the much lower energy use that we would expect from modeling. And when you compare that to the LEED and code, other buildings that were built in the same time frame with similar scale of projects, we're talking about, compared to the regular code ones, it's 62% less energy use per square foot, which is pretty dramatic. And then we're finding pretty consistent information in Philadelphia also, which has that energy disclosure ordinance. So on the left are 3 passive house multifamily projects. All of these are just the affordable ones. And you see this, it's very interesting, right? Because the green passive house ones, there's not much up and down. And that's not surprising, right? We have a lot of verification and blower door after blower door during the process of passive house. So I think it's much more likely that you're going to see what's designed actually built. And look at the variance in the code buildings, lots of variance. And you know, some of these, I actually do know 1 or 2 of these were aiming for net zero, but no certification. And so that's what, you know, you can see some of these energy use per square foot are in the same range as a passive house, but it doesn't guarantee anything, which is really interesting. Then here's another example. This is basically Gilford Village. There were 2 stages of this. It's basically the same building built twice, 4 years apart, one with the LEED standard and one with passive house standard. And again, we're seeing around 61% less energy use in those buildings. And I think a lot of people know this one. This was sort of a stealth energy project. There were 16 townhouses between 2 and 9 units in Taunton. And this is just on the heating energy. So it's not exactly equivalent to the energy use per square foot. But again, we're seeing very, very dramatic decreases in energy use for very modest incremental costs. So that's really encouraging. So I'm going to hand it off to Michelle, who's going to talk a little bit more about the Gloucester project.
Awesome. Thanks, Beverly. So it's critical to design it right, which takes intention and a team. And then it's also critical to build it right, which takes communication and craft. And in the end, what I'm seeing like real time when we have projects that have committed to doing commissioning and tracking, monitoring, and Tom's going to get into some of this, we've got to confirm that what we intended is actually functioning as intended. Next. There we go. So I'm going to talk about Harbor Village today. The Distillery was our first passive house multifamily project, and it was in the city of Boston. This is our third. Harbor Village just was completed a couple of months ago, and whoo, passed the blower door test. And let me tell you, it was with a lot of pins and needles on the way. So I definitely have some lessons learned here. Also want to do a shout out here. Look at that fabulous lobster. This is our client in the North Shore who loves to put art on buildings, and it's just so iconic and fabulous. Next. So we have we started passive house projects in 2010. We now have 3 built: Distillery, Finch, and Harbor Village. All they're in green at the top. We have a number that are just about to start construction, and we have a number on the boards as well. And all of that is to say, holy smokes, how crazy exciting is that? Like, how is it possible that right now we have like 15 passive house projects in our office? Next. And there are a lot of really good reasons for that, which aren't just because passive house makes so much sense. They're actually because there's been a lot of great groundwork done. And so Beverly talked about Mass CEC, but those design incentives were critical to jumpstarting the broader market, and that's really what Mass CEC is focused on. Before that even happened, passive house was actually acknowledged in the building code as an alternative compliance path. I don't think that made much of a difference for the most part. But then those incentives came, and a handful of projects pursued them, and that ultimately opened the window and the door for the utilities to weave that concept into their incentives. And we are, again, very lucky in Massachusetts to have the Mass Save incentives, which ultimately focused not just on affordable housing, but any multifamily housing at scale. And so we're starting to see some of the market pay attention. And I will say that a lot of that is not just because of the incentives, but it's because there is a lot of great community engagement and advocacy going on right now, really encouraging cities to evaluate more seriously what buildings are allowed to go forward and make sure that they're meeting the goals of the broader community. So I cannot say enough about that advocacy, because it's definitely the reason that we have market rate clients coming into the picture right now and trying to understand how to make use of these incentives. Next. It takes a huge team. I don't want to undersell it. I probably even missed some people here, but it's everybody on the design team. It certainly starts with the owner, having the mindset, the commitment, the openness. But we need all kinds of other consultants to help us get there. So the teams are getting bigger and they need to communicate, which is why we're going to focus so much on that piece of equation. And to Beverly's point, like, the modeler, the rater, verifier, these consultants that help us make sure that things are actually happening the way we intended along the way is just fundamental to doing it effectively and cost effectively. Next. So here we are again, Harbor Village. So now I want to we do a lot of work on the design side, no doubt. Happy to chat about that at another time. I think a lot of architecture firms are getting up to speed. They're really, the baseline is evolving. But as great as we might design it, we still ultimately have to have it built, right? It has to be executed properly, and that really takes craft. And I think that our industry has sadly been losing proper focus and value of what craft really means in the built environments. And so, we're trying hard. Most of the projects we're working on, it's a contractor who hasn't built a passive house project. That's totally normal because there aren't that many that have been built. So we can't assume that they've done the training necessarily and all of that. We need to help them get up to speed. And so we're trying to speak their language so that we don't make it scary. We actually just make it kind of fundamental to the process that they probably are already going through, but maybe just need a couple of tweaks to make sure that they're executing as intended. So the schedule is critical. And here is sort of a typical 3-week look ahead, right? So the contractor every week comes out and says, here's what's happening in the next coming weeks. And all we want to do is recognize where these aspects of upcoming work might interface with some tricky or important passive house level details. And that's not all of this. Most of this doesn't come into play against that, right? But there's going to be something at the foundation, something at the podium, some exterior wall work. So we try to kind of flag those. Next. And then as a team, just talk about the sequence of events and what we're thinking is going to happen. So here's an example. This is from the contractor. You can see Groom there. They are articulating to us what's coming first in the next couple of weeks, which is in red, what's coming second. And all of these things actually, or some of these things, I should say, bump up against our passive house enclosure and important details. Next. So if the team can understand that, then we can say, oh, okay, in 3 weeks, we're going to be working on this scope right here. Let's dig into this particular sequence and what we, as the architect, thought was happening and the way we detailed it, and talk through it with the appropriate sub-consultants that are relevant for this particular sequence of work. We don't need to bring everybody into the picture. We don't need to have a whole passive house, kumbaya moment. We just really need to say, okay, you're going to be bringing, the stair shaft out of the ground, and it matters to us. So let's look at our details. Let's articulate what we think is happening for second and third, and have the trades on the line to talk with us about that. And we have found that within a half an hour, every couple weeks, like just having a time available to have this conversation about the future sequence, not at the job meeting, but kind of separately as needed, we can get the right people on the line. We can very quickly evaluate whether what we envisioned is feasible or whether we might need to make some changes. And we certainly often do. We're architects, we're not builders. So we sometimes imagine the sequence in a way that actually isn't feasible or isn't the way it was bought out. And so having those conversations is just so efficient. And every trade just brings their expertise to the equation. And then we can walk away going, okay, this is what we're going to do. We all understand it and we can move on. Next. So these are examples of how we have kind of talked through that process. It's an evolving conversation as we're learning to try to be more proactive before things happen, and just make sure that all the right people are at the table to have that conversation. And then, of course, we're referring to the details that are set that, like, we thought told us what we needed to do. The last, but like not at all least important piece is to really evaluate after the fact and to test and verify. And so that's during construction, and that's why that rater verifier, and we love the protocols around FIAS's certification. But also other tools that can be used during the process to evaluate where we have some weak points, like infrared, camera work to see if we're missing insulation in certain places. Clearly, the blower door testing is fundamental. It's pass fail, right? So we got to get there. And I'm not going to go into the weeds because Tom is going to do that for us on how we struggled at Harbor Village. But a smaller project, a small hole just makes that much more of a difference. So it really does get harder and harder. And it's important to understand how to chase the problems and find the solutions. And thank you, New Ecology, for helping us to do that. And then ultimately, we pass the word test, woohoo! But the systems, are they working right? Like, is everything functioning properly? The thermostats, the ERV, are the temps set right? All of that. Are tenants complaining? And that can go on for a while, and it really does take tinkering. And I couldn't emphasize enough that every project should have commissioning built in. And with that, I think I'll turn it over to Tom.
Great, thanks, Michelle, and thanks, Bev, for the introduction. So I'm going to quickly talk through the process of midpoint to final whole building blower door testing, and to set the context a little bit for folks who may be used to blower door testing of single family buildings. Let's say even small multifamily buildings are complicated in terms of the different assemblies that come together, materials, and this one is no exception. So New Ecology was the passive house verifier on this project, and we view that role both in terms of confirming that what was designed got built and that the building can be certified, but also as one of the entities doing troubleshooting. And I think about a lot the fact that there's only one full-scale model we ever get to build, and there are some things we find out when we build that full-scale model that we didn't really get in earlier models, even in 3D. Although a lot of really great effort has gone into understanding what's getting built before we get out there in the field. And so this is a list of the midpoint to final whole building blower door test results. And what you'll see here is that we try to test early and often, even maybe before the whole exterior envelope really is ready to be tested for the air barrier, so that we get a sense of where our problem spots are and where we need to focus. And then as the envelope gets buttoned up, we continue to test and really narrow down that leakage to the very small leakage number that you get for a passing whole building blower door test for a passive house building. So next slide. I want to show some images of what that looks like, that testing. So here's some photos from the first test. In the lower left, you see that we haven't got some doors in, we haven't got some windows in. So we're starting to put up temporary barriers so that we can get a sense of what the leakage is. And we find some of the big spots that aren't sealed yet, and we can target those. Things like where structure is coming together and hasn't been closed out yet, penetrations, mechanical penetrations, or potentially items we didn't plan for. Let's say understanding how the gasketing actually works on a roof hatch. Next slide. And as that envelope starts to come together, we still have some locations in later tests or later midpoint tests that are still being finished, like the top of the elevator here on the lower right. Some mechanical penetrations. These are smaller than the earlier ones that we found, so we're continuing to narrow down those leakage locations. Next slide. And again, we're getting down to the really fine details towards the end. We start to push air in places we hadn't before in earlier tests, and to those smaller places where we can continue to seal and hit our final result. And next slide. This is what things look like at the end. At the end, very few leakage locations remaining. Some that are really lessons learned for future projects. How do you do a lot of conduit through a slab that's also an air barrier, let's say? Really tricky. This is a great find in the image on the left, a window that was delivered and installed with part of the gasket missing. So some of our minor remaining leakage is really just a last item to button up and make sure that we get that product repaired prior to closing out the project. So that's the process. Lots of testing early and often throughout, but really troubleshooting to make sure that we get there in the end. I think that's it for me. Thanks.
So Chris, would you like to, well, actually one quick thing. I know you guys made some mention of difficulties towards the end. Do you want to just quickly comment about that?
Yeah, maybe I'll start and Tom can back me up here, but the exterior envelope is really not hard. It's the transitions that are really hard. And so in this case, we excluded some particular spaces on the ground level, and that meant that we had adiabatic, separations that were thermally fine but needed to be airtight separate, and those interior separations are difficult. And so I think the good news is that even as we weren't failing, it was clear from great testing that Tom's team was doing with, I don't want to say smoke because that's not the right term, right, Tom? But following the trail, right? Where's the air going? And luckily, and I think this has been, we experienced this at Finch as well. Luckily, it's usually pretty easy to kind of isolate the weak zone. It's not the whole building, it's a zone. And our zone was the lobby. And so we put a lot of energy into how do we figure out where the air is leaving the lobby unintentionally.
Yeah, that's exactly right. So that fog testing was that small lobby area, kind of filling it with fog, pressurizing it, and following the fog to locate where our leakage is. It always impresses me to look up the number for any given passive house project of allowable leakage area to really understand how tight these buildings are. For a building like this, it's less than a square foot over the whole envelope with all of its perturbations and movements and just massive square footage. So that's a really small number compared to what folks are used to too. And so I think that is one of the lessons learned for the general contractors team, that really was an aha moment that said, wow, we built a really tight building. That's an incredibly small amount of leakage.
I would just add that having the contractor there for that last test with a team of people who could literally seal openings like in that moment, right? You're hearing, they were walking through the building, hearing air move, right? In certain places was really important. And I think maybe we should have done that earlier to have them there and able to kind of track and address in the moment.
Agreed, yeah.
And what was the problem?
Holes, just holes.
Mailbox area, right?
Yeah, we don't even know why though, really. We still don't really know why, but for whatever reason, there were holes there.
All right, I'm gonna let Chris jump in now with our Northampton project from Community Builders.
Great, thanks Bev for the introduction. So as Bev mentioned, this is North Commons at Village Hill. It's a new construction project in Northampton, Massachusetts. And it's currently under construction and we're anticipating a end of 2021 this year completion. So we're getting close to wrapping up on this one. Next slide. Great, thank you. So a little quick overview of some facts about the building. Just over 61,000 square foot, including a conditioned attic space, which is one of the challenges we kind of had on this job, and we'll talk about that a little later in the presentation about why that was a challenge. We also had some architectural design restrictions on the project based on the campus that's located. It has sort of a craftsman style, a lot of pitched roofs with different slopes coming together, which made for some complicated interstitial transitions. As Michelle pointed out, those transitions are really the challenging part, and we certainly had a lot of those on this project. We had also mechanically, it's a VRF mechanical system with a V ventilation system. Talk a little bit about that. This also is a little unique in that for its domestic hot water, we had a propane fired central hot water system, which is a unique challenge to this project based on some local kind of requirements of the city. And we also have a 58 kW rooftop PV solar array on the building to help with some of our energy usage on the project. Next slide. So as Michelle had mentioned, communication is also really important on this project. The general contractor had some experience with high performance buildings under different programs, but didn't have any passive house experience. So as part of our bidding process, TCB made a requirement of the general contractor for their site super, their project manager, and their project executive to attend the phase 1 of the FIA certified builder training program, just so they were a little bit more familiar with the project. Certainly it was a risk to us to go with a non-experienced passive house contractor. And we wanted to try to eliminate as much of that risk as we could. So in addition to the training we requested or required the contractor to go through, our passive house consultant and rater also did 2 independent on-site trainings, one for the building envelope trades and one for the mechanical MP trades. And really it was to go over both general requirements of passive house and then some of the specific details of our project and some of the critical areas they were worried about as potential downfalls to the project passing. You can go to the next slide. So this is an overall view, sectional view of the project, kind of showing some of the complex pieces of how the different roofs come together. It's all wood framed, 3-story building with a conditioned attic space. Really, the attic space was used to run a lot of our ductwork. All the control boxes for the VRF system are located up there. And it's hard to see in this image really, but combination of spray foam insulation at the underside of the roof deck on the pitched roofs, and then at the flat roofs, a combination of both closed cell spray foam on the underside and polyiso on top of the roof. You can go to the next slide. So here you can see some of those transition details that were both identified as critical by the passive house consultant and things we went over during that training with the subcontractors to get them up to speed. Things like overhangs, over entries, transitions from the pitched roof to the flat roof, really kind of maintain continuity of both the air control layers and the thermal insulation layers throughout the building. You can go to the next slide, Ben. So domestic hot water source, I know, is typically a hot topic related to full electric buildings and all their kind of energy efficient processes that projects go through. So at the time of design, and currently the city of Northampton has a gas moratorium on new natural gas services. Despite it being available on the site to us, it wasn't available to us because of that moratorium. So we did consider an all electric building. This building was designed about 4 years ago. So at that time, really it was hard to get an electric system that would meet the passive house requirements, be efficient, and really make it viable for this project. We did look at it. We had our passive house consultant run the numbers. And at the time, FIAS was seeing electric being about 3 times more energy intensive than the propane system. So we ran through those numbers, and in the end, if this same exact design had used the electric hot water, we would have failed passive house requirements. So that was the tipping point for us. We really had no choice but to go with the propane system. So we have 2 underground storage tanks, 2,000 gallons each, located on the site that'll feed our central domestic hot water system. Go to the next slide. So I talked a little bit about this quickly. The pitched roof concept really is different than what other kind of multifamily buildings you typically see now. Typically, it's a flat roof with a parapet, a little easier to deal with from an air control transition standpoint. You can see here, the roof sheathing and the wall sheathing were really stopped at the same plane so that we could tape continuously from the wall sheathing to the roof sheathing. Typically this is not how you would frame a wood frame building, right? You run your rafters over the top plates, extend them out to create your overhangs. But that becomes a really challenging spot to air seal when you have framing members at every 16 inches protruding past that wall envelope. So this became a challenge. Certainly contributed some to our incremental cost that Bev showed that this project was the highest one that they've had so far. This alone, just for the framing to add this detail, was about a $30,000 premium to this project. Once you add in all the framing, the Simpson hangers, the tiebacks, sequencing, taping, and then coming back and framing it, just a lot of different challenges that add to the incremental cost of this kind of detail. You can go to the next slide. So as others have mentioned, testing and verification, really critical component to ensure that the built condition matches the design requirements. So not only did we, obviously we'll go into some of the FIAS rated inspections on site, we also had the contractor build an off-site mock-up in his shop, showing wall connections to slab connections, that roof connection that we're really concerned about, and as well as a mock-up of the typical window installation. We had our passive house rater come in and do some testing on the envelope, on the window, and it did lead to some changes in the design, detailing for constructability, making sure, it's a fine balance between keeping water out and keeping air out, right? You want weeps to let water out, but you don't want weeps to let the air in. So it's a fine balance that we went back and forth with multiple times, multiple details to get this really right from both a constructability standpoint and something that would meet the passive house requirements. So we went through the process, everyone signed off, and then we moved to the field. So we can go to the next slide. So we took what we learned in that off-site mock-up and we built an on-site mock-up in the actual building, actual window size, and we tested that first window. Everyone was up to speed, on board, and we had some really great testing numbers on this. You can see the target was 1.779, and ours came into average 0.821. So really substantially better than required. Great kind of installation detail. You can see some of the ceiling behind the clip. So these are an Intis window with a clip installation fastener. So they get snapped kind of into the frame of the window and then attached in to the jamb framing. You can see some of the continuous caulking behind that clip and over the clip, which is really a requirement to help control any potential air leakage at the clip itself, which was good. And then some nice continuous caulking around the ceiling of the perimeter of the window. You can go to the next slide. So unfortunately, we all thought we were on the right track after that, and we came back as the passive house rater was doing some other testing. They said, we're on site, we'll test another window just to make sure we're still doing what we're supposed to be doing. And we found that the next window failed the test. And what we found was that at some point in the project, the subcontractor who was installing the windows and doing the framing switched their on-site foreman. And there was some lost in translation kind of information about what we were really supposed to be doing here to make sure those passive house details were met. So you can see some sloppy kind of caulking around the window clips, but really the bigger issue was the ceiling around this angle back dam that we had at the sill. So the original detail called for a continuously set and sealant angle to kind of serve as an air block on the backside. And the new foreman was not aware of that kind of requirement. He only spot sealed it. So we were getting leakage through multiple points at that windowsill, which really caused this window test to fail. We ended up going through multiple buildings, having the contractor check every single one, and we found about 40 windows that had to be replaced. Luckily, this was caught early enough where we could do it. It wasn't a scheduled test. We just happened to be there. We figured we'd do some more testing while we were there. So certainly good if you have the ability to test more often than not. Certainly recommend it so you can avoid last minute changes. Obviously, if this unit had been drywalled and finished and then we tested it at the end of the job, it would have been a lot more work to repair it than when we were able to catch it early on. I can go to the next slide then. So we also have, as I mentioned, closed cell spray foam insulation at the underside of our conditioned attic. There was some thickness verification testing, which was relatively straightforward. Really, what I want to point out in this image is since we had that conditioned attic, which is part of our envelope, all the spray foam, not only was it, thickness required multiple lifts, which added to cost, it also required an intumescent coating since it was exposed to the envelope of the building, which added, just so for the coating alone was another $25,000 add to the project. So when you're thinking about the passive house design, trying to keep any of those critical details that may be atypical that might cost you money later on. Even though we had a fully sprinklered system in the attic, we still needed to put the intumescent coating on the spray foam. So another contributor to our high incremental cost. So like I said, we're still under construction, but we have started some of our testing, unit compartmentalization testing. which we're passing really well. We've done kind of the third floor units, which are the smallest units, so the least kind of tolerance for leakage based on the square footage that Tom was talking about. And for our contractors being their first job at Passive House, they're passing really on all colors other than the window test that we talked about. So really happy so far. And we're optimistic that that's going to continue through the rest of the unit tests. You can go to the next slide, Ben. So in July, around 50% completion, we did do our first intermediate whole building blower door test. Some of the things Tom pointed out as well, we did have to seal up some openings based on construction progress at that time. So here's a door being sealed up. We also had numerous electrical penetrations coming into the mechanical room that all had to be capped and sealed, which was a little time consuming for the contractor to do. Really the most challenging sealing was we didn't have all of the plumbing fixtures hooked up yet. So we had to seal the sanitary sewer system in the road to alleviate any leakage through that system that wouldn't be there when the system was fully intact. So that required shutting down the road, opening up the manhole, going in there, sealing it at the manhole connection, which required this test to be on the weekend when no one was there. So there's some extra costs that the owner, we had to incur to get our team out there on the weekend to do this test, which is not really considered originally. All in all, the building door test went really well so far. You can see we're at 0.31 ACH 50, so we're well beyond kind of the Passive House requirements right now. We're getting close to kind of the end of the project, so we're getting ready to gear up for our next kind of round of whole building blower door test, and hoping the results. We're cautiously optimistic the results are going to be in line based on everything we've seen so far. So that's kind of a quick overview. Hopefully that was helpful, everyone. Ben, we'll turn it back to you.
Yeah, this is great, this kind of detail. So wonderful to hear two different projects, different approaches, what's similar and what's a little bit different where the hangups have been. I definitely feel like the more lessons and we learn from each other, the less problems we'll have in the future. A couple of comments, Chris, I know since this was designed so long ago, 4 years ago, the central hot water heat pump systems there weren't that many of them. I do hear there's some more sort of on the horizon. You see Sandon a lot in Canada, for example, and even in DC. And I think there's a new Mitsubishi VRF hot water kind of system. But I guess that's one thing that I think will be changing. I will say all 8 of the projects that we provided some grant funding to, all of them have hot water gas, high efficiency gas central systems. So we haven't completely gotten fossil fuels out of these buildings, even when the overall energy use intensity is so much lower. Michelle, I see you nodding your head. Do you want to say anything?
Yeah, I just add that this is the nut to crack, right? We're desperate to figure out how to, heating and cooling can be all electric, no problem. We got that. Ventilation, no problem. Hot water is tricky at smaller scales. It's totally doable. We've seen it. We're certainly seeing some samples at larger scales, but most engineers, it really is a testing ground and we haven't totally figured it out. And it's partly about right sizing the systems that exist for the load that these units have. And at the moment, an individual approach is really not feasible in all electric unless you're doing electric resistance, which is really not what we're trying to get to. We're trying to do something more efficient. So we're starting to look at our current projects and anticipate additional space that might be available in the future if the system were to shift and become all electric down the line. And that's an if, right? And there's a lot of variables. It definitely takes up more space. There are condensers that need to be located. So it's not an easy switch, but that's really, we're waiting for the market to help us to catch up with what we need, I think.
I do know of a couple Sandons in the Boston metro area, I will say. So there are some people doing it. It'll be very interesting to hear how those go.
Right.
Another observation, Chris was mentioning that his is the highest cost. It's still pretty low. Let's talk, we're still within contingency here. And honestly, site conditions are going to be in some cases way bigger than that. And I think even the increased cost is really design decisions, which I think Chris's building was designed not thinking of passive house detail. And if you can think about that a little in advance, that's, you know, the complexity of the roof lines with that one compared to some of the others, that really explains a lot of the difference. So Chris is the only project that did have additional costs related to roof insulation and air sealing work compared to the others. But I think that's just because it was not designed specifically to try and minimize that kind of interaction. So if you know from the beginning you're to go passive, you can probably go with a more simplified approach. That's not necessarily just a box. I mean, I will say I love the 8 of our projects because they're all over the size range, right? They go from 30 units in this Harbor Village all the way to 135. And you see a very traditional look in some cases with brick. The Gloucester one, to me, like fits right into Main Street. I actually walked right past it at the ribbon cutting. Didn't realize that was a building we were going to.
That's what they were going for. They wanted to look like it'd been there for 100 years. So that's that.
And then you see like the Hanson and the Holbrook one, which we don't have a picture of, but they look like very traditional sort of suburban affordable housing. There's still peaked roofs, but you know, 3 stories longer. But I actually think Dakota Partners, their Hanson one is like a template that they're trying to use over and over and over, and it's sort of a suburban situation. So it's great to see all the variety and also the different communities that we've been hitting all over the place. Any last observations from any of our panelists?
I just add, because you did mention, Chris, and you're totally right. I think the vast majority of the multifamily passive house projects in our region thus far have been flat roof buildings. I think that is changing. We have a number of more traditional looking buildings underway right now with gables and et cetera. So it'll be really interesting to sort of understand some of the science around that, right? That's equipment inside the envelope versus outside the envelope. Like there are some nitty gritty details there that we're going to want to dig into.
Yeah, that would be great to see. Even in ours, we have outside equipment that penetrates that envelope and then goes into the conditioned attic. So there's some challenges there as well that we ran into. So it'll be definitely interesting to see how others handle that moving forward.
Tom, last thoughts?
I would just sum it up by saying, you know, it's doable. We're doing it. Let's do it times 100.
Let's go. Let's go.
Yeah, I think last time I checked with the Mass Save program, there were 86 projects that had at least taken passive house modeling money. So we don't know all those will certify, but that's a huge change, right? From one project a few years ago to potentially 86, that's huge. And we're actually seeing other communities looking at those kinds of incentives. So Connecticut, Eversource territory is using the same model of providing money for feasibility studies and the modeling. And my understanding, Tom might know more about this, is DC Green Bank is actually looking at better lending terms for passive house projects based on some of this performance kind of data that we're seeing. So thank you everyone for joining us today. We're going to have a Q&A session now that's going to be open, so stick around.
Thanks all.
Thanks all.
Thank you.